Okay, so I'm going to be working problems 1 through 4 from the sample problems in Math 1050. So I'm going to start with number 1. And number 1 asks convert 2.86 radians to degrees. So again, I'm going to be multiplying using a conversion factor, and we should know that we have 360 degrees in 2 pi radians. So if you get the calculator and you just type in 2.86 times 360, and then you divide that number by 2 pi, we would get 1.6, we would get 163.8659 ... And I began with 3 significant figures, so my final answer should only include 3 significant figures. So I will end up with approximately 164 degrees rounded to 3 significant figures. And the second question, it says convert 23.9 degrees to radians. Again, we're going to use the same conversion factor, but this time we're going to use the reciprocal of the first conversion factor. So we're going to have 23.9 degrees times 2 pi radians per 360 degrees. And that way, again, look, the units cancel. Degrees in the numerator cancels degrees in the denominator. We end up with radians. And if we were to punch into the calculator 23.9 times 2 pi divide 360, we'll end up with something like 0.417134. Again, I need 3 sig figs, so I'm going to approximate my number to 0.417 radians. And number 3, it says convert. So we want to convert 22 degrees, 32 minutes, 53 seconds to degrees decimal. So we want to take degrees, minutes, seconds, and go to degrees decimal, to decimal degrees. So the way that we would do that is we already have the 22 part, the first part, it's in degrees. So I have 22 degrees, and then I want to add it to one of the conversion factors that we should already know is that I have 60 minutes in 1 degree. What does that mean? That means I can take 32 minutes and convert it to degrees, to decimal degrees, by saying, okay, 32 minutes times, and then I'm going to multiply it by 1 degree. I have 60 minutes. So we divide. So we'll be dividing 32 divided by 60 and 0.53333. So I would keep 5 sig figs at this point. And this would be degrees. Okay, so we have the 22 degrees. We have now converted the minutes to decimal degrees, and I'm going to do the same thing to the seconds. We should also know that we have, in 1 degree, we have 3,600 seconds. So we would divide the 53 seconds by 3,600 seconds, and then I would get 0.014722222. So again, I'm gonna keep 5 significant figures just for now, and then I'm gonna restrict it to 6. The final answer is gonna be restricted to 6 significant figures. So see, I have 22 degrees. I've converted the minutes to decimal degrees. I've converted the seconds to decimal degrees. And all what you do now is you say 22 degrees plus 0.5333 degrees plus 0.014722 degrees. And we add these up, so it'll be plus 22 plus 0.3333. So the final answer to 6 significant figures would be 22.5481 degrees decimal. So this would be our final answer. And why is it 6 significant figures? How did I know that? Because if you look at the initial problem, 22 degrees, 32 minutes, 53 seconds, 6 significant figures. So my final answer is restricted to 6 significant figures. So if I were to, I'm just double checking something real quick and I'll be back. And if I were to say, so we would have 22.548, yep, that looks right to me. And then number 4, it says convert 45.8731 to degrees. Now, number 4, the 45.8731, I believe this is in radians. Okay, so this is in radians, and we need to convert it to degrees and then take it to minutes and seconds. Okay, so the way we would do that is the first step, I know that 45.8731 radians, we will use the same conversion factor. So we have 2 pi radians, right? In 2 pi radians, we have 360 degrees. So when we multiply this out, 45, 87, 31 times 360 divided by 2 pi. So I would end up with an answer 2,628.335023. And this is in degrees. Now this is a bit large, but anyways, we can work with it. So the way we go now from 2,628.335023 degrees decimal to degrees, minutes, seconds is, I already have the 2628. That's a whole number and it's in degrees. So I'm going to take the decimal. I'm going to take the decimal part, and it is 0.335023, and the units on it is still in degrees, right? So I'm just taking the decimal part now, and then we would use the same exact relationships. So we know that in 1 degrees, we have 60 minutes. So you'd multiply that decimal number by 60, and we would end up with 20.10139089. And the reason I like to keep all my decimals, that way I decrease my mistakes along the way as far as like accuracy with the final result. So now the 20 portion of this decimal degrees is also my whole number in this for the minutes. So now I have 20 minutes, and then I'll take the decimal part of it. So if I were to deduct 20 out, I'll end up with 0.1013989. And now, actually, this is minutes. This is minutes. When I take this part out, I know that, what am I going to multiply with? What am I going to multiply by? We also should know that in 1 minute, we have 60 seconds. So when we multiply this by 60, we end up with 6.0834534 seconds. So I just want to go over one thing really quick. You take the radians and we multiply by the first conversion factor, which is 360 degrees over 2 pi radians. My radians units, numerator cancels denominator. I end up with 2,628.335023 degrees. The whole number portion of this, decimal degrees, the 2628, that's degrees. So I will take the decimal portion now, which is still in degrees, and I want to convert it to minutes. So my relationship in 1 degree, I have 60 minutes. So I'd multiply the decimal by 60 minutes. Degrees cancels degrees, and I end up with 20.1013989 minutes. So the 20 stays, and I take the decimal portion. The 0.1013989, that's still in minutes. So I need to convert that to seconds. And the way I would do that is in 1 minute, I have 60 seconds. And when I multiply across, I should end up with 6.0834534 seconds. Now, the question asks to round to the nearest second. So that means I look at the number to the right of the 6.0, right? So 0 is below 5, so I will keep 6 seconds. So therefore, my final answer in minutes, in degrees, minutes, seconds should be 2,628 degrees, 20 minutes, 6 seconds. I'm going to continue working the other problems, but in a different video clip, just to decrease the time amount per video clip.